Okay, our main focus today will be stem plots, splitting them, back-to-back stem plots, and we'll get into histograms, all different ways to display quantitative variables. Not categorical, those are pie charts and bar graphs are the main things we do there, but quantitative data, something we can find meaningful averages for. For example, right, the number of shoes that females have. 49, are you kidding me? Please tell me somebody in this room doesn't have 49 or 50 shoes. 57, for crying out loud. It's ridiculous. All right, so here's the best way. Remember the stem plot, you've probably seen this before. They're also called stem and leaf, but us sophisticated statisticians just call it stem plot. All right, so you guys will now because you guys are going to be sophisticated statisticians as we move on. The stems, here's kind of the steps they're breaking down here for you. This is the success criteria. The stems consist of everything except the final digit. Maybe it might be something you want to add there. Stems consist of everything except the final digits. Okay. The leaf is the final digit. Because you can use stem and leaves for decimals like GPAs, 3.9, and so they're not always just this size of number. We can use them for different sizes. So we got to know this format. All right. So simply put, and you always put this in order. It says arrange the leaves in order from the stem. We also got to make sure we add a key. That is also something that will be expected on your assessments. Okay, you can mark down if you don't because they'll mark you down in May on that. All right, so we just kind of go through what's the smallest one we see. We see 13 shoes is the lowest, which is probably more shoes than what I have. And that's the lowest for the girls. So you can label it this way too if you want, stems and leaves. All right, so since the final digit is supposed to be my leaf, that 3 is going to be the first leaf. All right, and I've got a stem of 1. All right, don't crowd your leaves, right? You can just put a little bit of a space, like if you're typing numbers, maybe a couple spaces, and then you go on to the next data point. And you keep going. Okay, I got the first stem for you. I'm going to pause here and let you continue on. Go through, put them in order, get used to making a stem and leaf. All right, there it is. Just we'll quickly skim through and make sure you didn't miss any data points. Notice they're all in order. Yours should be in order. All right, because if they're in order, it's a quick little way to, quickly find the median because you can, how many students were selected? 20. So we know it's supposed to be between the 10 and 11. So I can just do it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it's between 26 and 26. So the center is 26. But if it's in order, it's easy to do. Okay. It's also a good way to view the distribution. Kind of looks like a dot plot, right? Like if I turn it sideways, I can also see that this distribution is maybe slightly skewed right, but you can kind of treat it like a dot plot in a way. You can see how it's laid out. Don't forget the key. Somewhere, grab a data point, like the 2 and the 3. So 2/3 represents, you could, I guess, simplify it a little bit more than that, just equals 23 shoes at the minimum, but I was pretty specific here. Female student who has 23 shoes. Questions? Good, great. Let's move on. Okay, so for the warm-up, I had you guys already read page 32, splitting stems. So let's go ahead and take a look at the textbook and talk about these concepts. Okay, so when do we want to split stems? If one row has too many data points, sometimes it's hard to see some of the gaps and see the entire distribution as well as you should see it. All right, so, and sometimes hard to tell when to do it, but this is a good pointer right here. 5 is a good minimum, the number of stems to use. See, this one has 4. So that'd be an indication I don't have the data spread out enough. All right, so what this data set is they asked the same question to some males, and it's a pretty crowded distribution on the 0 through 9s and the 10 through 19s. So they split it. So this first row is 0 through 4. The next one is going to be 5 through 9. You guys follow me on that? This is going to be 10 through 14. This is going to be 15 through 19. So by splitting the stems, they cut that in half, right? From 0 to 9, cut it in half. There they are. Now look at the distribution. Entirely different. If I turn this to the side and take a look at it, we see an outlier. Okay? That outlier was hard to see here in the first one, but there's a big gap, right? Most students don't fall in this big gap. It's pretty uncommon to have these outcomes. All right, so we split stems to better see the distribution if you don't have enough stems. 5 is a good minimum. Okay? All right, continue reading these bullets if you haven't already, and let me look at the context of the back-to-back stem plot real quick so we can talk about that because I can't remember. Go ahead. Okay, the idea of back-to-back stem plots is to compare distributions. In your assignment yesterday, you compared dot plots. All right, now it's a lot easier to tell. All right, so they put the females on the left, males on the right, and these are the distributions where you looked at. Okay, and so it's pretty easy to see the center of the females is a lot higher than the center of the males. You can quickly check how the distributions are shaped differently. This one's skewed right. This one was also slightly skewed right. I know it looks left, but remember it's below the number line. But it's positively skewed. That's why we also like to use that number. It's skewed in the positive direction, which makes it right skewed. Okay. All right. So back to back is a good way when comparing distributions. Okay. With that being said, let's go ahead and try to check your understanding. Answer it right in your notes. Here's the solution real quick. I'm not going to go through it because I already did, but it's right there. Pause it if you need to read it. And then there's 2, 3, and 4. Okay, another handy way to display quantitative data in graphs is histograms. Okay, so let's read this and read the context of this problem, and then I'll explain how these histograms are made. Go ahead. Okay, so why wouldn't we use dot plots? That's the first way we talked about displaying quantitative data. Well, if you look at these, I don't really have anything that repeats itself, right? Dot plots, you need something to stack on top of each other, like 5 siblings, multiple responses. Probably nothing is repeated here, okay? Maybe a couple values. So that wouldn't be reasonable. Stem and leaf, that might be okay. We could use like a stem of 2 and a leaf of 8 and put the key as, 2/8's 2.8 and have a stem of the 2's. That might be okay, but usually once the data gets very large in quantity like this one does, now we might want to use a histogram. Okay? Since we got 50 pieces of data here. All right, so this is what a histogram looks like. Let's take a look at the next page. Usually they give you some type of direction on how to divide the classes, but once again, just like stem and leaf plots, we want at least 5. At least 5 classes. So I don't want to make a class like 0 to 20 and then 20 to 40. That would be 2 classes. Okay, so they broke it up into a reasonable range to make sure they have at least 5 classes. We like to use clean numbers, so they chose clean numbers of 5. All right, and then you got to go through and create a frequency table or a relative frequency table. Okay, frequency table is counts. Relative frequency is going to be percents. So they go through this chart and 0 to less than 5. That's important because if something's 5%, we need to know where to put it. If it was 5%, it's going in this category, in this class. So 0 to 5, they went through and they counted all the states that responded 0 to 5, and the quantity of those states was 20. Okay, so we're just tallying up. Total's 50 states. Okay, sometimes chicken scratches helps for you to get to your final count. And then here it is in percent, right? 20 divided by 50 is 40%. This will add up to 100%. Okay. Why don't you go ahead and continue to read this, and then, go ahead and read this, and then I want to talk about the think about it on the next page. Give you a couple minutes to read this, and then over to page 35. 3 or 4 minutes. Go ahead. Okay, let me help you wrap this up and talk about some things, and then we'll try it. They're just making a point here that whether it's relative frequency, percent, or if it's counts, the distribution is going to look the same. That's, same data. This just says this bar here, it's a count of 13 states, right? And over here it looks identical, but now it's percent, right? And if you look at the y-axis, it's 26%. But they're both skewed right. They're both going to have the same general outcome when we decide the shape, center, and spread and outliers of it. Okay. All right. This think about is pretty good too in the next page. I don't know if you got to it or not, but it just kind of shows what a histogram is really doing. If we were to make a dot plot of all these, I guess they round to the nearest percent. I just told you they wouldn't stack up. They wouldn't if we use decimals, but I guess if we rounded to the nearest whole number, they would stack up. So we're taking all of these states from 0 to 5 and we clump them all together into this connected bar graph. It's not a bar graph. Don't call histograms bar graphs. Bar graphs are for categorical data. And you see categories down here, right? Okay, opinions or whatever we're measuring. Histograms always have numerical values down here. Okay. All right. So yeah, we're taking all these data points, stacking them up like this, and then that's the quantity. Take this, stack it up from 5 to 10. Okay. So there's a good visual aid of what we're doing on these histograms. All right. Okay. Now this is the first time we're going to do it, so we'll kind of go through this together. Let's take a look at this. Check your understanding. IQ scores of 60 fifth grade students chosen at random from one school. They're shown below. Okay, so we're sticking together on this. You kind of want to look, when you're choosing to decide the class size, you kind of want to consider what is your range. The range is 81 to 145. Okay, if you're going to make your own histogram, I made note here, or just pay attention and understand if you don't want to write it down. You choose the class size, just make sure you choose at least 5 classes, whatever range of values. Like I don't want to make one class from 80 to 110, right? That's going to be too big, because then if I do that same class size of 30, 110 to 140, I'm only going to have a couple classes. So maybe something around a size of 10 would be more reasonable, because that's going to give me 6 or 7 classes. All right, so let's stay together on this. Let's start at 80, nice clean number, and class size of 10. Start at 80, class size of 10. So what we have to do first is organize this into a table. So I'm going to get the table going for you and then let you go on this. So step 1, make a table. So I did it over here. Make a table first. IQ scores. 80 to 90, we have to know what to do with the score of 90. I can't just do 80 to 90 and then pick up 90 to 100. That less than sign is very important, because this is 80 to 89 now, isn't it? Okay, so 80 to less than 90. Now, the reason I didn't do 80 to 89 is we make our scale, it's a continuous scale. I don't want to do like 0 to 4.9 and then have 5 next to it. We like that continuous number line of 80 to 90 to 100. So we just say less than 90 in our table. Okay, so go ahead and get that set up. Start counting them, crossing them out as you go, and tally them up. Okay, because that's what I'm going to put next to this. Okay, I'm just going to put, I just labeled counts, and I'm going to count them up. Okay, I'm trying to keep this under 15 minutes, so you can check your understanding in the back at home if this is too quick here for you.